Now, welcome everybody to Abayo News Zone. Today, our discussion is ISOQUANT. I'll be discussing ISOQUANT, and by the end of this video, you should know the meaning of ISOQUANT, you should know the properties of ISOQUANT, and also you should know how to analyze the graph of ISOQUANT. So now, let's continue with our discussion on ISOQUANT. Now, ISOQUANT has to do with the production of two variables. Now, when we discuss the short run analysis, when I was discussing the law of diminishing returns on the card above, I made emphasis that only one input is fixed, the other varies with the level of output. But in this case, when we are discussing ISOQUANT, the two variables varies with the level of output, which is in the long run. So the ISOQUANT can be referred to as a long run analysis. So now let's continue our discussion. Introduction. Here, our discussion is based on the long run, like I said earlier, in which all factor inputs, which is labor and capital, varies with the level of outputs. Thus, we will use the ISOQUANT curves. We use the ISOQUANT curves to illustrate the long run analysis. So the long run analysis is called the returns to scale, and you can check the video above where I discussed the returns to scale and homogeneity of production function. You can check that on this video. So now let's go into the next slide, which is what is ISOQUANT? What is ISOQUANT? Now, the ISOQUANT curve is a locus showing the various combination of two inputs, which is labor and capital. For example, two inputs which use the same level of output. That is, when we combine this labor and capital together, we must have same level of output. That is what the ISOQUANT is. And these two inputs can be used together in the production process by substituting one factor for the other. So while we are producing, we have to substitute one factor for the other in order to produce a specific amount of output. And in order to produce a specific amount of output, and that is substituting capital for labor at a diminishing rate. So now, in our next slide, I will explain what I mean by diminishing rate. Now, let's go on by analyzing this graph. Now, on the vertical axis, as you can see on the vertical axis, we have capital, which is K. On the horizontal axis, we have labor. Now, and this is our ISOQUANT. This is the curve of the ISOQUANT. And this is another curve of the ISOQUANT. That is, we have the first and the second. The one here signifies that there's a shift to the right in the ISOQUANT curve. And when there's a shift to the right, that means output increases. Now, when the ISOQUANT shifts from a point to another point, that means there's an increase in output. Like here, at the initial ISOQUANT, we are producing 100 units of output. Now, when the ISOQUANT shifted from this point to this point, there was an increase in output by 100 units. That is, now we are producing 200 units of output. I hope you get that. And now, When we are talking about the isoquant, like I said, I want to explain what I mean by diminishing rate. Now, as we move along the isoquant curve, we have to substitute a certain amount of capital for labor. And as we move downward, we have to forego a certain amount of capital for labor. Now, as we go on, the quantity of capital reduces and the quantity of labor increases as we move along this curve. As we move downward, the quantity of capital reduces and the quantity of labor increases while producing same level of output, which is 100, while producing same level of output. I hope you get that now. Now, let's move on to the properties of isoquant. But before then, when we have several isoquants in a particular graph, for example, we can have another isoquant here, we can have another isoquant here. It is called the isoquant map. Yes, it's called the isoquant map. When we have several isoquants on a particular graph, we have one here, one here, one here, and the other here. We have one here. Let's call this another isoquant. Let's call this one another one. Then we have isoquant map. I hope you get that. I hope you get that. Now, let's consider the properties of isoquant. Now, isoquant has negative slope. That is, as you can see, the curve is negatively sloped. As you can see, the curve is negatively sloped, and this means that a certain amount of capital must be given up for more of labor. That is, the lower the quantity of labor, the lower the quantity of capital, the higher the quantity of labor. That is what the negatively sloped means. It has to be negatively sloped. That is, the lower the quantity of capital, the higher the quantity of labor, as you can see on the graph here. Now, the next property is the isoquants cannot intercept or tangent to each other. They should not intersect each other. That's another property. Another property is they are convex to the origin. Now, as you can see, the shape is convex to the origin. That is, it becomes more difficult to substitute a certain amount of capital for labor as we move along this isoquant map, this isoquant curve. As we move along, it becomes more difficult and hard to substitute capital for labor. That is what we have as the convex to the origin. And when we say something is convex to the origin, that is, we have to substitute some amount of a particular factor input for another in order to remain at a specific output, in order to make output constant. That is it. So I hope you got so much value from this video. So you can move on to the next video where I'll be discussing the marginal rate of substitution, which is the slope of the isoquant. See you there. And please don't forget to subscribe to my channel and also like this video. Thank you very much and see you next time.